Hello friend, welcome you all once again to my channel CCP and SEAFARER. So here I am with the next part in which we will discuss induced coefficient B, that is denoted by IB. So this is the topic. So for the definition purpose, for your exam purpose, you can write the definition, and here also I will try to explain how it form and how it affect. So from the definition you will see it is the maximum value of semicircular deviation, which is just now we study in our permanent IB, means permanent coefficient B. In that one which we have already discussed, it is a semicircular, like we have discussed already. The coefficient is circular, means 3 out the 3 out 60 degree, it will be either east or west, or if it is circular. And semicircular means it is either by this way or by this way, in which it will be either east here, west here, or west here, east here. It can be this side also, east, west. So we'll see which one will be which type of semicircular is here. For now, definition. So semicircular deviation which varies as, the point here to mention it, varies as sine of compass course. Sine of compass course means compass course, from 0, 0, 0 degree till 360 degree. So sine of, this is sine means trigonometry. So here the sine means the sine 0 is 0, and the sine 90 1, again sine 180 and sine 360. So if you are going to make the curve of this, it will vary like this. Sorry, 1, again 0, sorry, 270 and 360. So it will vary like this, if it is plus 1, if it is minus 1. So the meaning of this is sine of compass course means something like this, which we'll discuss later when we'll come to the second part of the of this topic, where we'll discuss again these things. So I just need to mention here that sine means the sine means sine 0, 0, sine 91 maximum. So if it will plus side, then that will become plus IB, and if it is on the other side, that will become minus IB. So we'll discuss later, that time it will be more clear. So is caused by, which we have already seen, all the this deviation is being caused by something, either it will be it is because of the induced magnetism or permanent magnetism. So here since we are studying this induced magnetism, so we will discuss for the induction of the induction by the earth magnetism. So by horizontal magnetic field, in our previous video we have already discussed what is horizontal magnetic field, what is vertical magnetic field, Z and H. So horizontal field magnetic field, that is denoted by H, in which it will be either fore and aft or port and starboard, that is earthward shift. So horizontal magnetic field means in this case it is not being explained for upward and downward, not a Z force. So here it is horizontal magnetic field at the compass position, means at Monkey Island where the compass is located, due to induced magnetism. So the point is due to induced. In previous part where we are discussing about the permanent coefficient B, PB, that time it was because of permanent. Permanent is what we have already discussed, that when vessel is constructing somewhere, so the hard iron of that vessel, like hull, longitudinal, and those things, those parts which has been permanently magnetized to the either red pole or blue pole. But here it is induced, means it is because of it temporarily, because of the earth magnetism. So that difference will be more clear when we'll draw the diagram 360 degree. So induced magnetism in vertical soft iron. Here the point is soft iron, because it is not hard iron, means this is not going to be permanent or sub-permanent. It is just momentarily. Till the time you are there, it is inducing or pole is forming in your soft iron. Once you go to the other side, means suppose for a while, that if you are in northern hemisphere, so the pole is forming in that way, and that I will discuss later which type, this how that pole will form. And as soon as your vessel is going to southern hemisphere, that polarity will change, means blue pole will become red, red will become blue. So that thing we'll see later. So vertical iron, here the point is vertical, means we have many types of soft iron. It might be vertical, might be horizontal, horizontally fore and aft direction, or earthward shift direction. Like if your ship is like this, so one horizontally like this, so this is fore and aft direction. So this is also horizontal. This is horizontal soft iron. There might be some longitudinal or something like this. So this is become a horizontal, but in earthward shift direction. So in the same way, like our funnel is there, which is a perfect example of a vertical soft iron, which is in up and down direction. So that thing is vertical soft iron. So forward or aft of the compass. So this iron, particular this iron is whatever the iron which is depends on the construction of the vessel. It might be either forward or aft of our compass, where the magnetic compass is located on our monkey island or wherever. So that vertical soft iron, there will be some induction due to the earth magnetism, and that induction will temporarily deviate our magnetic compass needle, and that deviation we have to calculate from here, and that is what we call induced coefficient B. Now we'll see for the purpose of this part, you can make it a note that if it was the same in the our previous video in permanent B, that if any field is acting towards forward, that will be considered as positive. If it is forming towards aft, then that time it will be considered as negative. So you can also say that in terms of rod, if this whole definition will talk, just now I told you that in terms of rod, if you say which rod will be going to induced and which rod is going to make develop this type of induced magnetism, then this rod, C rod in C, in which we have already discussed all the 9 rod. So C rod means one vertical rod. If you have not seen that video, then just go to the part second or third video, I don't remember. You go there, all the 9 rods are easily and very easily explained there. So that 9 rod is very important. That time also I told. So C rod. Now also again we'll discuss what is C rod, and we'll see how induction is going to happen on all 360 degree on our next slide. Yeah, so here now we are with the C rod. So for you just need to notice here, I have taken one example in which this is because this is induced magnetism is forming. So it is for induced magnetism vessel, it depends on the vessel's position, where the vessel is. It is either at equator, northern hemisphere, southern hemisphere, where it is. So for this one, I have taken one example that vessel is in northern hemisphere. So now if you remember, or if you have not seen see previous video, we have discussed when we are talking about our earth magnetism. In earth magnetism, we have discussed that in our earth core, if we discuss about that one, then there is blue pole, blue pole in the northern side and a red pole on the southern side of our earth magnetism. So because of this one, suppose our vessel is in northern hemisphere, so this vessel is in northern hemisphere, so earth magnetism is blue there. So whatever the pole will form near to the earth, that will be just opposite of whatever is here. So suppose this is funnel which is continuously like a rod. If you consider this as a rod like this, then since it is in northern hemisphere, so in northern hemisphere of earth it is blue, so the pole which will form here will become red at the bottom and blue on the opposite side. So this one become red and this one become blue. So this funnel is acting like a soft iron, in which red is forming at the lower. You can say if your compass is here, then you can say it is a farther pole. So farther pole is red and the effective pole which is just near to the compass is blue pole. So now how will it affect? I have already told you that we will not discuss anything about the blue end of our compass needle. So whatever we'll talk about only the red pole. So suppose your compass is here, which was initially towards the forward, but because of this because blue pole is forming here, so this blue pole, how will it affect this needle? It will try to attract towards it. So when it will attract towards it, your needle will act towards the aft. So that's why I have made here the compass needle is acting or deviating towards the aft. And in our previous slide, I just told you, if it is acting towards aft, it will become minus. If it is acting towards forward, then it will become plus IB. So it is acting towards aft, that's why it become minus IB. So what and for this one only I have drawn this cardinal and intercardinal condition or the deviation for the 360 degree, in which we'll see. So this diagram is for vessel in northern hemisphere, in which the C pole means blue pole is forming just before the compass. If suppose it is actually not practicable or not possible on our vessel, if this funnel was somehow anyway, just for example, was forward of our compass, then again this blue pole will forming here, would have formed here. So how will it act? It will act towards, our needle will act towards forward. So if it will forward, then it will become plus IB, but that is not possible in our vessel, on merchant vessel. Some other type of vessel might be, but in our merchant vessel such type of construction is not there. So only the funnel is there, which acts like a C rod and which affect our magnetic compass. Now the main thing people don't understand is how does directive force and how does this deviation form. So here we'll see, we have already discussed that whatever the horizontal force is there, that I have draw here with a black ink. So black ink, that will always act towards the north. So wherever you are constructing this, blindly you just make your compass and make a needle towards the north, means completely towards up. Here this black one, it is very difficult to distinguish between black and blue, so I'll just indicate here. So the one which I have marked here in the upper direction, this is natural alignment of our needle, which is towards the north. It is because of our horizontal force. And since this C rod I have drawn here, C rod which is blue, I have drawn it aft of my compass, so it is here aft of my compass. In this direction also, because of H, this arrow I have drawn, this is also because of H, that is horizontal force. This is also because of H, this is also H, here it is H, everywhere I have drawn this H like this. So this is all H, this is because of our horizontal force, which is because of our earth magnetism. Now the second thing, this is the induced magnetism, which is going to be induced on our soft iron, which I have told about, that C rod, that is funnel. So because of that, one pole is forming here, which is blue, and that is on the south side, means on the other side of our compass, on the aft side of our compass. So this blue and compass, we have already told that we will only study for the red end of that compass. So the red end of that compass will be attracted by this blue end. So that will, suppose this is because of H and this is because any force you can take as a P. So it is trying to take it on the opposite direction. So the deviation, if you say, if suppose something is going like this and you are trying to pull in the opposite direction, the deviation will be no there. There will be no deviation, because just if you talk in, just to understand in a term of magnitude, something, suppose just I am taking a arbitrary number, that is 10, and if you are trying to pull it in the opposite direction with something with a 5, then what will happen? Only the magnitude will reduce to 5, from 10 it will reduce to 5. So same thing happens here. Because of H, whatever the force is forming toward the north is being pulled out by this induced magnetism, and which is just reducing the value of that horizontal force, but not deviating. It is not creating any fulcrum, or you can say it's a moment, rotatory moment or something. So it is just whatever is going towards the north, it is just pulling it to south. So magnitude will be less, but deviation will be no deviation. It will be in the same direction. It will remain in the same direction. Just the magnitude will same. So directive force, that is what directive force I told you. So this time your directive force is what I have already discussed. That directive force is something which is towards the north. The force which is acting, which is creating a turn or creating a force which is acting towards the north. That is directive force. So it was because of the H, and now P, this is acting completely towards the opposite. That's why directive force here is decreasing, maximum decreasing this time. Once we'll come to the 360, then you will notice here that it is maximum decreasing here, because one was totally towards north and the pulling was totally towards the south. So maximum force is acting, and that's why this deviating force is become maximum decrease. Now come to the second one, northeast cardinal mark. So here this H1 is towards the north, and blue pole is just aft of the vessel. So this is after this is your vessel. So after this is this. So one force, you can say just say this is as P. So this P is acting towards this, and H is acting towards the resultant of both will somewhere like here west. So deviation is, see, the needle which was here on the northern side, it is coming towards this like this. So deviation, you can say it is a westerly deviation. This is westerly deviation. And now directive force, I told directive force was maximum here on the north side. It is still in the north. Directive force is still there. You can say it was in the north side. And if you see, if you make here a coordinate of 360 degree like this, you can see if it is 90 degree, if it is 270 degree, it is 000 degree, and this is this is 180 degree. You can see this force is somewhere in the southwest side. So this force is acting towards this south side, not anything on north side. If it is northeast or northwest, then that component will add something to the towards the north, but it is something towards the south, so it will reduce the north component, which is by h. So this is reducing. That's why directive force is decreasing here. Same thing once you will come here, that will be more clear to you. Now here deviation is same, like this is because of h and this is because of your induced magnetism. So how it is affecting? Resultant will be resultant I have marked here with the red. So resultant is somewhere here. So your needle was initially supposed in this direction, and because of this induced magnetism, it is coming towards this. So westerly deviation. But now we come to the directive force. So how was your directive force? It was north, towards the north, and something is pulling towards it. Like suppose this is the pen which you are trying to pull it towards this. Means what is, you are trying to pull the whole system, not you are diverting towards the any direction, or the east or the west, or in other way you can say it is either east or west. So in east or west you cannot change the direction towards the south, or neither you are adding something towards the north, because east means 090 degree or 270 degree. It is not forming any direction towards either north or towards the south. So that's why there is no change in directive force, because here why it was decreasing, because this component was towards south, here this is towards the west. So it will, how it will work is, suppose something is here, it is just pulling like this, but it is not reducing the magnitude of this. Here it was reducing because it was somewhere here and it was something towards south. If anything towards south or towards north, if it is north, that means it will increase. If it is something towards south, it will decrease, but it is on any cardinal mark, that will not affect. That's why here no change in directive force. Like suppose here in this direction southwest, so it was already on the north. Now you see this, because of this blue P force, it is something towards northwest. So something is north, means it is adding to your H. It was also in north, and because of this it is also something in north. That why directive force is increasing. That's why I made a arrow up. And deviation, your initial initial neutral position was like this, and because of this induced, the resultant is somewhere from here to here at the position of red. So it is somewhat west. Same way will come on the southern side. Initially the H was on the north side, and blue pole is also on that side. So blue pole is also attracting the red end of your needle, so it is also pulling up. So what will happen here? H and P both are in same direction. So what will happen? Whatever the directive force was because of H on the north side, the same something is adding in the same direction in north only, and that is by P, because both are on same side. So what will happen to the directive force? Both are in the same direction exactly at the north. So the maximum increase will be there in the directive force at that time. And in the same way, like here we discussed how the deviation will not change, because it was exactly in the opposite direction. So magnitude may be reduced, but the direction will remain same. So there will be no deviation. Here what happened? It was in the north and it is being taken to the north. So the magnitude will increase, but there will be no deviation. So deviation will be nil, and directive force will be maximum. Same opposite of that will be here. This H is because of our horizontal force, and this blue one is this P is because of our induced force. So initially our needle wanted to be here, but it is being pulled by this P and it is coming towards it. That's why it is deviating towards the east. That's why here I am marked easterly deviation. And directive force increasing. Why? Because it was in northern direction because of H, and because of this P it is somewhere in the northeast direction. So north component is involved there. So it is something adding to this H or to the directive force. That's why it is, suppose this F force is there, H1 I marked it is a force F. So something a small f is also adding in that, and that is the resultant of the directive force. And here this small f was something subtracting from that. That's why it were reducing it. So now here it will come here. It is same like that. Deviation you will see it is going here. So it is easterly, and this directive force it is just pulling towards the east, neither not deviating or north, neither north south component is involved, neither north component, because it is totally east. So neither of the component is involved, so it is neither increasing nor decreasing, so directive force will remain same, no change. Here sterly deviation again, now you know how, why, because it was north and the force is somewhere here, so it will deviate towards this direction. So sterly deviation, and directive force will be decreasing, directive force will decrease. Why? Because it was somewhere north and the component of this blue force is something, if you make a coordinate over here, then it is something towards southeast. So something south is involved, means it is decreasing, it is reducing the north component. That's why directive force is reducing and becoming it less than what was initial. So I hope this there will be no problem with this directive force in your whole topic. This is all concept, this is the concept of directive force. If you feel any doubt, just write in comment box. I will try to make it clear to you. So just now we'll go to the next slide where we'll discuss rest thing related to this IB. Yeah, before we'll go to the next slide, one more thing here. Now I guess you will be able to tell me that which type of this semicircular deviation is being formed here or forming here. Like what I told here, it is minus IB is forming. So minus IB, I have already told you that in any semicircular or circular, if you will take from 001 degree to 044 degree, if it is coming east, means it is plus. If it is coming west, means minus. Now you see here, if we'll go from here to here, the deviation is westerly, 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 and here on the cardinal mark, no deviation. So this is west and this is east. You can see here the whole this 180 degree, everywhere it is easterly. So that's why I told you, west. If it is west here, so this thing also tells you that it is minus IB, because it is west here on 001 degree till 044 degree. 044 degree it is west here. So if it is west, means I minus IB, and you can see or you can compare the same thing, because all the deviation on westerly deviation is on from 000 till here it is 180 degree. All the deviation is westerly and here it is easterly. If you take it plus C rod, then it will become completely opposite of that, and you will have easterly deviation here and westerly deviation here. So this is the point you should correlate with the previous 9 rod, which we have told there, or we have already studied there, how you can correlate this thing with that 9 rod and this plus and minus. Now let's go to the next slide. Okay friends, so as we have discussed that all the coefficient will be studied in 5 terms. The first one is definition and cause, and also the nature. So definition we have already seen, cause of the induction is already seen, nature also seen. Now the second one is change in direction due to change in course. So that we have already seen on our 360 degree, but when we come to the to describe the same thing in the graphical form, so here it can you can say, or you can compare with the previous slide in which we are showing on all 360 degree, because it was minus IB in our previous slide where we are discussing, that was minus AB. So in minus IB you see all the at 90 degree it was maximum westerly deviation. So you will see here the maximum deviation, that is at 90 degree it was westerly, the maximum deviation was here. That's why the blue curve is because of minus IB, and this red curve is because of plus IB. So this plus IB, if plus IB will be there, then that will be more deviation at 90 degree towards the east. So this is the curve of that. You can verify this one with either with the definition in which I mentioned that it caused because of the sign as of the sign of course, or in our previous diagram also we saw that on all the easterly course it was west deviation, and all the westerly course it was east deviation, because it was minus IB. The same thing here, on the easterly course it is showing minus, all the westerly course it is showing plus, and if it is plus IB it will be opposite of that. So this is what is change in deviation due to change in course. Now the third thing which we have to study is change in deviation due to change in position. So that's why I have taken 3-4 position here. So this is suppose your earth, this is equator. One position I have taken in the northern hemisphere which is near to the equator, and other one is further away from the equator. and one direction, one position also I have taken here just to make you understand, in the southern hemisphere. So for this one IB, it is suppose H1 is Z1. Wherever we'll study for induced magnetism, there will be two forces, so that is H and Z, and that will be because of earth magnetism, so it will be always present there. So H and Z, as we know that value of H is maximum at the equator, and it is keep on reducing as you go toward the pole, and the value of Z is maximum at the pole, and it is minimum at the equator, and in between it will change according to the same. So here I have taken this position, and because we are talking about the minus IB, so I have taken this radar here. So since this is earth, and in earth northern hemisphere is something blue, so because of this blue, the red end is forming here, and if it is red here means blue is here. Same way it is red here, it is blue here. And since in southern hemisphere, this is southern hemisphere, so red pole is here, so whatever will form here and there on our soft rod, the blue at the keel, and blue pole at the keel, and red at the opposite side. So red is here, so because of this red, the force will act towards the forward, and plus IB will form here. The same it will come here, so this is blue, so it is acting towards the aft, so minus IB here. Here also minus IB. So this is because of our H and Z. So because H and Z both are induced magnetic field, and both are varying at various locations from equator to pole, that's why we have to consider two cases, and in both cases we'll have to assume one thing, because we have three variable here, force because of this H and Z, and one is because horizontal force. So three constants are there, that's why if you have two equations, then you can find out the one with one equation, one what is it, constant value, and one is variable, then that variable can be find out the one equation. But here there's three, so we require two equation at least. That's why I have taken two cases, in which one, in first one I have assumed Z is constant, means vertical force is constant. Now you see the at position H1 value of H is higher because it is near to the equator, that's why H1 is here. And H2 because you are going towards the pole, so H is reducing, that's why I have marked there H1 is something small force. Now I have considered this Z is constant, so this force will remain same for both, because this one I am taking constant for the purpose. So F will be same for both H1 and H2, and because of these two forces H and F, the resultant, you can say R1 and R2, that resultant. So first resultant is here, second one is here. So because of this one, this is the deviation which I have written here H1, and this is the deviation which I have written H2. So you see here H1 is greater than H2, but the deviation 1 is smaller than deviation 2, because here it is less deviation than deviation 2. But to verify this one, we have to take other way, in which we'll take this value constant and this value as variable. So suppose H we are taking, this is for a particular location, just for understanding that this H is constant for both. So what will happen, Z, how the Z will form, Z will keep on increasing as we go towards the pole. So Z, whatever Z is here, the value of Z here will be more than this one, so means Z1 is less than Z2. So because of Z1, F1 is less than F2, because here we are considering H is constant, here we are taking H is constant. So if H is constant means F will be varying. So F how is varying, it's as per the Z. So Z is how the Z is minimum at the equator and maximum at the pole. So H1 is near to the equator, that's why F1 is smaller than F2, means that is Z2. So because of this, the resultant one is this, resultant 2 is this one. So the deviation because of this is this one, deviation 1, and because of this is deviation 2. So R1 is smaller, and same way the deviation is smaller. R2 is bigger than that one, and deviation 2 is bigger. So H1 is less than Z1 is less than Z2, and same way deviation 1 is less than deviation 2, means this is directly proportional. And here you can see it is inversely proportional to H. So if you see here, if I write here deviation 2 upon deviation 1 just to formulate, this is not much important for our exam purpose, but if you want to go more detail in this thing, then that time already required, or if examiner or if you are in oral, that time examiner is asking you to just to know your concept is good or not. For that purpose it is good, or as far as our question concern, MMD question, it is not much important for us. So it is just for understanding. If you are not able to understand, just let it go. So deviation 2 and deviation 1 of IB. So we have already seen here, it is directly proportional to sine of course. It is forming as per the as the sign of sine course. So it is directly proportional to sine course. Means if we are writing here deviation 2 upon deviation 1 means course directly proportional means course 2 upon course 1 means 2 means 2 1 1, and it is also directly proportional to z. So if we are writing 2 up, so z2 upon z1, that is inversely proportional to h. That's why I written here h1 upon h2, and you know h upon z is something called dip, tan dip. Z upon h is tan of dip. We have seen our first part of this video. So this z2 upon h2 is tan dip to h1 upon h2 will become tan dip 1. So if you come here, sine of course 2 upon sine of course 1 into tan dip 2 upon tan dip 1. We can write it in this form also. Or if we have an example, we will say like we see, if it is given us IB2 upon IB1 equals to tan dip 2 upon tan dip 1. So here suppose it is given there something 60 degree, something 10 degree, -6. So we can easily find out this value, but related to this, no, never this type of question has been asked, but just to make your concept clear on this, I am discussing this, otherwise it is not required much. So in our next slide we'll see how the directive force is acting, and thereafter we'll see the correction, how to correct such type of deviation or induced such type of deviation, how to correct and how is being corrected on our ship. Just wait for next. Okay, so 3 point we have already seen. So the fourth point here is mean directive force. So mean directive force will not change, because we have seen already that on a particular heading it is increasing, but on the same opposite side heading it is reducing the same rate. So okay, at a particular heading it is increasing, at particular it is decreasing, it is changing, but throughout means total mean, if you say mean directive force, so mean directive force there will be no change. And one more thing, if you like in our previous video slide we saw, and what all the 360 notation we talked about minus IB. So on minus IB you saw on the northern heading, it was decreasing maximum, means directive force was minimum, and on southern heading, because both are on same side, so it was increasing. So directive force north is less than directive force south, that indicate it is minus IB, because we saw that time when vessel was on northern side, so the compass it was like here and blue pole was here, so it was decreasing. So the directive force was decreasing maximum decreasing. Same way when we are on southern hemisphere, the compass was here and blue pole was here, so our because of force H it was on northern side, and because of this blue pole it was also adding something, so directive force was getting more and more, so and it was about minus IB. So means directive force on north is less because it is decreasing, or you can say decreasing maximum. So directive force north is less than directive force south, that indicating it is minus B. So it is also one of the indication to know whether it is minus IB or plus IB, and just opposite of that, if you make the plus IB, it will be there. Now four things we have already seen. Now the last thing here is correction, how to correct such type of correction or error. So why this error was coming? Because of C rod was, what is that? That is funnel, means there was a soft iron just behind our magnetic compass. So how to correct it? And the other ways we can say, just put another funnel forward of your compass, then that will cancel out each other, and your this deviation will be nil there. So but we cannot put the funnel there. So what we used to do is we used to place a vertical soft iron, not in form of funnel but in some other way. What is that? That is flinder bar. So since since the funnel is on up side, that's why we are putting this vertical soft iron on forward of the compass. And this flinder bar, just for your knowledge, the diameter of that is 3 inch in diameter, total 24 inch in length, and it was divided 12, 6, 3, and the same figure of that, it is reducing to less than a half, means half of 1.5, that is 0.75 inch. So from there till 12 inch. So we need to put these soft iron in the form of flinder bar forward of your compass. How is it? Like see, like suppose this is your compass, this is your compass, and just forget this one, just forget this part, just focus on this one. So this is your flinder bar, this is your magnetic compass, and minus IB because of this ship's funnel, minus IB was forming here. So now what we have to do is, if it was towards the earth, we need to put it, we need something which will make it towards the forward. So how will you do this? This is your flinder bar casing. So this casing is called brass casing, in which we have flinder bar in this casing. So the material is brass. Many second officer does not know, if you see in your navigation log, wooden piece are given in the same form as flinder bar. So that wooden piece is equivalent, wooden parts are provided, that is for flinder bar, because that bar is not so long. So you just need to do, what you need to do is just put wooden pieces at the bottom, and on top of that you can put the soft iron. So that will, now suppose here we are putting here flinder bar, so this is soft iron, so this will also get induced. And suppose your vessel is in northern hemisphere, so the way your funnel is inducing means how it is inducing here, if it is in northern hemisphere, then a red pole is here, and blue pole is on the top. Same way this will also form, blue pole on the bottom and red pole on the top, So how it will affect, same way means red, yeah, blue pole will on the top and red pole on the bottom, So the same way how it will affect, this one will try to pull here, and we are putting something near to this which is inducing and affecting more than this, what is affecting the funnel. So it will try to pull towards the forward. So the induction we have to put that flinder bar in such type of, means the length and everything with such way that it will just cancel out this minus IB. So this is corrector which will form plus C, that is plus IB, you can say. So just it is cancelling out this minus IB effect with this plus IB effect, and that's why this and in this way we can correct this minus IB effect. But the one more thing here to notice is, like suppose this is your compass, and you are putting flinder bar here. So this flinder bar will induced in the same way, like your funnel is inducing here, red and on the top is blue, red and blue here. Same way this one also. Now you see, if you are putting a smaller height of flinder bar of soft iron here, then see red end is also forming here. So this red end will try to repel this red end of compass needle. So it will try to create a force in this direction. Now this blue end will try to attract this. So this force is creating here, one force is this one and one force is this one. So the resultant, now which two forces we have, this force and this force. So this force will of course be smaller than this force, because this is near to this is further from this one. So the resultant will be somewhere here, and it will remain horizontal towards your compass or compass ball, or you can say the in your dial. So that's why the length of this flinder bar mean a lot. So now how this one we verify whether we have to put the larger one or the smaller than this. So for that we have I have a point here. If required length of flinder bar is more than 12 inch, if you see, if the length is more than 12 inch, top of flinder bar should be slightly above the compass card. If it is required more than 12 inch, then this one should be little bit higher than the compass, and if it is less than 6, the top of flinder bar slightly below the compass card. So if it is your compass card, in this case, because it is less than 6 inch, So this is just a point which you remember, or it is not much important, but okay, you should know this. And why it is so? Because it can create a particular amount of resultant force which will try to keep your needle in a horizontal way. So in the next slide, just we'll see 1-2 example which will make clear your doubt, and we'll also see how to, with the example, how to correct this IV. Yeah, so here I am with some example, but before we go to the example, we'll just see the coefficient B. We have already know there are two components, PB, that is permanent, and IB, that is induced coefficient B. So the how to calculate it, both are given here. Like suppose deviation east and deviation west, both are given there. So the concept is deviation east minus deviation west divided by 2. We can find out the total deviation, because on suppose in 360 degree it is somewhere increasing, somewhere it is decreasing. So how to get the mean of that? So deviation east, whatever the deviation east minus deviation west divided by 2, we can get it. So like for example, we take 10 degree east, yeah, but we have to take this one with the direction. So 10 degree east, like suppose this one 4 degree west. So how we calculate? 10 degree east means plus 10 minus, the formula minus is minus, and west will take on the negative side. So this is minus 4 divided by 2. So 10 minus minus positive. So that is 14 divided by 2. That is 7 degree, or you can say 7 degree east, because it is positive. So we can find out that the resultant is 7 degree east. Now the other example, now how if there is plus IB is 10 degree, vessel is northern hemisphere. So this is more important point. If in case of induced magnetism, in case of IB means induced. In case of induction, the hemisphere is very important. So northern hemisphere, describe the procedure of correction of IB. So here, if such type of question is coming, so first thing in your mind should come that if it is coming in northern hemisphere, the which type of pole will form. And since it is related to IB, means it is something related to vertical soft iron. So vertical soft iron means our funnel. So which type of pole? If it is in northern hemisphere, then our earth have blue pole on the earth. So the nearest one will become red. So it is northern hemisphere. So here it will be like this. So earth have blue pole. So here will be near one will be red. I am making this one for the funnel, and the upper one will become blue. And because of this blue, this negative minus 10 is forming, that is IB is forming, minus IB forming. So this minus IB is because of the ship. So now how to correct this? Now we have to put the flinder bar. Where to put the flinder bar? On the forward bar. So plus IB we have to create on the same. So that earth magnetism is inducing this one also, and that soft iron which will put as a flinder bar, that will be also influenced by that earth magnetism. So that one, if it is affecting from aft, we need to put something on the forward. That's why we are putting here a flinder bar of on the forward. So how will you correct? If it is given minus 10, means your this thing is on the aft side. So we just put opposite side a flinder bar on the opposite side, which will make it towards the forward. And that's why like how will you put? If you put a flinder bar here, then how it will form? Blue pole on the top and a red pole will be on bottom. So this blue pole will try to pull this one on the forward, and it will try to cancel out this minus IB effect. So place a flinder bar of appropriate length as you have already discussed, length forward of. Now the question is where we have to put, either forward or aft. So if we are putting flinder bar, the red pole is being forming on the further end, and at the nearest end, or which is the effective end, the blue pole is forming. So this blue pole will try to pull towards it. So we have to remove this minus 10, means we have to remove from aft to forward. So this blue pole, the nature of this blue pole is to attract, so it will attract towards it. So if you put on the forward, it will attract and it will cancel out minus A. So the answer is we have to put the flinder bar on forward side of the mechanism. Another question is flinder bar plus 10. The IB is plus 10, so vessel in northern hemisphere. So if here for here, just take southern hemisphere. One question is take for southern hemisphere. So if it is southern hemisphere, the first thing in our mind should come, if you go in southern hemisphere, then earth have red pole on the southern hemisphere. So whatever the pole will form here, the bottom will become blue and the further one become red. Now to put where to put, so it is already plus, means the force is towards the forward. We required aft. So if we are in southern hemisphere, we will put the flinder bar here. Then which type of this thing will form? Because it is in southern hemisphere, so red will be on the top. So this red will also try to push it toward forward. So this will not cancel out, but it will, if we are putting forward aft of the compass. That's why we will put something on the forward. We will put something on forward which will be red end, which will create red end on the top and blue end on the bottom. So this red end will try to pull the needle aft, and this, because it is initially plus 6, means that is in the forward. So this one will cancel out and correct the this error. So this is what, wherever the induction is there, we just have to see whether it is southern hemisphere or northern hemisphere. If it is northern hemisphere, then the in the earth it is blue, southern hemisphere it is red. So if it is red, then the any vertical or any something is there, if we are putting any soft iron, this the nearest end will be just opposite of this. So if it is red here, that's why blue is forming here, means toward the bottom side, and on opposite side the red will have automatically formed. If you go towards the northern hemisphere, so it is earth pole is blue here, so the nearest one, which is the lower one, will become opposite of this, means red. So the other one will automatically become blue. This is the concept behind the induction and regarding the creation of pole in a particular soft iron or iron. So here I will stop this topic here only, and from next part we'll see the coefficient C, and I will try to cover all the magnetism topic as soon as possible, so that the student who is preparing for the exam, they can get avail of that. So thank you for watching this video, and I will request you to share this video to your friends also, so that after seeing that they are viewing my video, it will encourage me to make more video. And